Restriction enzyme recognize specific base pair sequences in DNA called restriction sites. Cleavage the DNA by hydrolyzing the phosphodiester bond. Cut occur between the 3 carbon of the first nucleotide and the phosphate of the next nucleotide. The restriction fragment ends have 5 phosphates and 3 hydroxyls. Here the site of restriction enzyme, cutting of restriction enzyme. Cut DNA with restriction enzyme. Most restriction enzymes occur naturally in bacteria. Protect bacteria against virus by cutting up viral DNA. It defends bacteria, defends itself against the bacteriophage. Bacteria protect their DNA by modifying possible restriction site. For example, methylation. More than 400 restriction enzymes and more discovered have been isolated. Names typically begin with 3 italicized letter enzyme and source. E. coli, EcoR1. The source is E. coli, RY13. Hint 3. Haemophilus influenzae RD. Ham H1. Bacillus umbilicoficiens H. Many restriction sites are palindromes, 4, 6, or 8 base pairs. Short restriction site sequences occur more frequently in the genome than longer restriction site sequences. Sequence is symmetrical about the center of the point of cleavage. Here the digest of the EcoR1. Some restriction enzymes produce blunt ends, where others produce sticky overhanging staggered ends. Blunt ends. Sticky ends are useful for DNA cloning because complementary sequence anneal and can be joined actively by DNA ligase. Overhanging sticky ends is more important in cloning because we can stick the preferred or DNA we need to clone in these places. Ligate the 2 DNA with EcoR1 recombinant DNA. Here we cut with R1, leaving sticky ends, and we ligate the preferred or the DNA we need to clone, and here the recombinant DNA molecule.